Welcome to the video lecture for section 12.1. This is for MGF 1106 and my name is Jorge Gavillan. And so the objectives for this lesson: count elements in a set systematically. We're going to use tree diagrams to represent counting situation graphically and then determine the number of branches in a tree without drawing the tree. And so here we have some examples. How many ways can we do each of the following? Flip a coin, roll a single die, pick a card from a standard deck of cards, and choose a features editor from a 5-person newspaper staff. So the first thing, a coin can come up either heads or tails, so there's 2 ways to flip a coin. The die has 6 faces, numbers 1 through 6, so there's 6 ways the die can be rolled. There are 52 different ways to choose a card from a standard deck, and then there are 5 ways to choose one of the 5 staff members to be editor. Now, Engineers Without Borders chapter in your campus is raising money to build and install a water purifier for an orphanage in Honduras. They're planning to have 2 major fundraisers, one in the fall and one in a different one in the spring. They're deciding among online auction, air hockey tournament, theme road race, or karaoke. So how many ways can the chapter select the fundraisers? So as to not overlook any possibilities, we're going to list them all in pairs systematically. We denote the choices by the letter O, A, T, and K. So we can start assuming that O, the online auction, is selected for the fall semester, and then consider each of the other choices for the spring. So this gives us OA, OT, and OK. Now, if the group uses A for the fall, then the choices would be AO, AT, AK. And then continue in this fashion, we can generate the complete list. So there are 12 different ways to select the fundraisers for the year. Now, how many ways can 3 coins be flipped? So let's make the assumption that we're flipping a penny, a nickel, and a dime. So a tree diagram is a handy way to illustrate the possibilities. So first we're going to illustrate the possibilities for flipping the penny. Then we're going to illustrate the possibilities for the nickel after we've already flipped the penny. And then we're going to go ahead and illustrate the possibilities for the dime after already having flipped the penny and the nickel. So we can trace the 8 branches that indicate the ways 3 coins can be flipped. So it starts with HHH and then ends with TTT. So you can see that we have 8 possibilities. Now, if we roll 2 dice, how many different pairs of numbers can appear on the upturned faces? So we will use ordered pairs to form red number, green number to represent the pairs showing in a dice. We can roll a 1 on the red die and either a 1, 2, 3, 4, 5, or 6 on the green. So then this corresponds to the pairs 1, 1 all the way through 1, 6. And then we can use a tree diagram to illustrate all of the possibilities. And so you can see that there are 36 different possibilities. Now, Promotion Managers for San Francisco Giants is planning some special events during an upcoming 3-game homestand. At each game, one of the Giants World Series MVPs will be honored. The manager has invited Edgar Renteria, Pablo Sandoval, and Madison Bumgarner to participate. And how many ways can these MVPs be scheduled? So here we have a tree diagram: first game, second game, and third game. So these are all the possible ways we can schedule the 3 MVPs. Now we see that there are 3 players the manager can choose from the first game, then 2 possibilities for the second game, and then finally 1 player remains for the third game. So the manager can make 3 times 2 times 1 equals 6 different schedules. Now, need to get a new look without spending any money. You can use an app to help you visualize outfits using clothes you already have. Imagine that you take 5 tops, 4 pairs of pants, and 3 jackets, and you use the app to look at all the ways you can put them together. How many different outfits are possible? So imagine a tree diagram where the leftmost branches represent the choices of tops, the middle branches depict the choices of pants, the rightmost branches show the choices for jackets. So we begin the tree with 5 branches, 1 for each top. Then to each branch we attach 4 branches representing the pants. So we would have a tree with 20 branches. To each of these we attach 3 more representing the jackets, giving a total of 60 different branches. Therefore you'll have 60 different outfits to choose from. Now, there's actually an easier way of doing it, and we'll learn that in section 12.2. Thank you.